note regarding conductor derating and overcurrent protection, specifically Note D, is correct provided that there is not more than one outlet in the circuit. This is because the ampacity for multiple current-carrying conductors in a raceway serving multiple outlets uses a different derating factor, which is found in the National Electrical Code, specifically Table 310.15b2r. According to the notes within that table, the ampacity ratings provided in 310.16 are intended for single conductors carrying current independently. When multiple conductors are present in a raceway or cable, the derating factors outlined in 310.15b2 are essential and must be applied to ensure electrical safety and code compliance. Let's delve into the specifics using the provided chart and National Electrical Code references. Firstly, consider the ampacity of THHN conductors at 90 degrees Celsius as listed in Table 310.16. A number 12 American wire gauge conductor has an ampacity of 30 amps, a number 10 American wire gauge conductor has 40 amps, a number 8 American wire gauge conductor is rated for 55 amps, a number 6 American wire gauge conductor can handle 75 amps, a number 4 American wire gauge conductor has an ampacity of 95 amps, and a number 2 American wire gauge conductor has an ampacity of 130 amps. Secondly, it is crucial to understand the derating factors for current-carrying conductors as specified in Table 310.15b2. For 4 to 6 current-carrying conductors, a derating factor of 80% is applied. For 7 to 9 conductors, the derating factor is 70%. When dealing with 10 to 20 conductors, the factor is reduced to 50%. For 21 to 30 conductors, it's 45%, and for 31 to 40 conductors, the derating factor is 40%. These factors are essential for calculating the adjusted ampacity of conductors in various conditions. Thirdly, let's consider standard overcurrent device ratings, which are governed by Article 240.6 of the National Electrical Code. Common standard ratings include 15, 20, 25, 30, 35, 40, 45, 50, and 60 amps. These ratings are essential for selecting appropriate circuit breakers or fuses to protect conductors and equipment. Now, let's analyze the examples provided in the chart regarding maximum overcurrent protection after derating, referencing Article 240.4(3). When there are 10 to 20 current-carrying conductors and using a number 6 THHN conductor, which has an initial ampacity of 75 amps, applying a 50% derating factor results in 37.5 amps. In this case, the maximum overcurrent device should be 40 amps because you are allowed to round up to the next standard overcurrent protection rating. This is a key concept in electrical installations. For 21 to 30 current-carrying conductors with a number 6 THHN conductor, the derated ampacity is 75 amps multiplied by 45%, resulting in 33.75 amps. Therefore, the maximum overcurrent device should be 35 amps based on available standard overcurrent protection ratings. With 31 to 40 current-carrying conductors and a number 6 THHN conductor, the derated ampacity becomes 75 amps multiplied by 40%, which equals 30 amps. The maximum overcurrent device in this scenario is 30 amps, aligning with the calculated derated ampacity. Using a number 8 THHN conductor with 10 to 20 current-carrying conductors, the initial ampacity of 55 amps is derated by 50%, resulting in 27.5 amps. Thus, the maximum overcurrent device is 30 amps since you are allowed to round up to the next standard overcurrent protection rating. When there are 21 to 30 current-carrying conductors and a number 8 THHN conductor is used, the ampacity is derated to 55 amps multiplied by 45%, which equals 24.75 amps. In this case, the maximum overcurrent device should be 25 amps. For 31 to 40 current-carrying conductors and a number 8 THHN conductor, the derated ampacity is 55 amps multiplied by 40%, resulting in 22 amps. Consequently, the maximum overcurrent device should be 25 amps since you are allowed to round up to the next standard overcurrent protection rating. When employing a number 10 THHN conductor with 10 to 20 current carrying conductors, the initial ampacity of 40 amps is derated by 50%, resulting in 20 amps. Therefore, the maximum overcurrent device should be 20 amps. With 21 to 30 current carrying conductors and a number 10 THHN conductor, the derated ampacity is 40 amps multiplied by 45%, which equals 18 amps. In this scenario, the maximum overcurrent device should be 20 amps. For 31 to 40 current carrying conductors using a number 10 THHN conductor, the derated ampacity becomes 40 amps multiplied by 40%, resulting in 16 amps. The maximum overcurrent device in this case should be 20 amps. When using a number 12 THHN conductor with 10 to 20 current carrying conductors, the initial ampacity of 30 amps is derated by 50%, resulting in 15 amps. Thus, the maximum overcurrent device should be 15 amps. When there are 21 to 30 current carrying conductors with a number 12 THHN conductor, the ampacity is derated to 30 amps multiplied by 45%, which equals 13.5 amps. In this case, the maximum overcurrent device should be 15 amps. For 31 to 40 current carrying conductors and a number 12 THHN conductor, the derated ampacity is 30 amps multiplied by 40%, resulting in 12 amps. Consequently, the maximum overcurrent device should be 15 amps. Let's elaborate on the notes provided, focusing on how to derate multiple current carrying conductors in a raceway serving a single outlet. Firstly, locate the conductor ampacity in Table 310.16. This table provides the allowable ampacities for various conductor sizes and insulation types under specific conditions. Secondly, determine the derating factor from Table 310.15b2 based on the number of current carrying conductors in the raceway. This table provides the adjustment factors needed to account for the reduced heat dissipation capacity when multiple conductors are bundled together. Thirdly, multiply the ampacity obtained in Step 1 by the derating factor obtained in Step 2 to find the derated conductor ampacity. This derated value represents the maximum current a conductor can safely carry under the given conditions. Finally, if the derated value does not conform to a standard overcurrent device rating listed in 240.6a, then you are allowed to round up to the next highest standard value, provided that specific conditions are met as described in 240.4b. This rounding rule ensures that the overcurrent protection device adequately protects the conductor without nuisance tripping. In summary, correctly applying derating factors from Table 310.15b2 and adhering to overcurrent protection guidelines outlined in Article 240.4b are essential for ensuring electrical safety and compliance when dealing with multiple current carrying conductors in a raceway. Remember that the ampacity ratings listed in Table 310.16 are for single conductors and must be adjusted when conductors are bundled together.